Periyar Maniammai Institute of Science and Technology, Thanjavur. Think, innovate, transform.
Hi learners, in this session we will see about hydraulic turbines. Hydraulic turbine comes under the topic of hydraulic engineering. Hydraulic engineering is an engineering which deals about the applications of water in the machines, that is in the hydraulic machines. Hydraulic machines, we will have two types of hydraulic machine, one is of turbine, another one is of pump. Turbine, it is a machine which converts hydraulic energy into mechanical energy. Here the hydraulic energy is nothing but pressure energy or kinetic energy. This mechanical energy is rotational energy. So the turbine is a machine which converts hydraulic energy, that is pressure energy or kinetic energy of water, into mechanical energy. The last, it is converted into electrical energy using a generator. The pump, it is also a machine which converts the electrical energy, that is mechanical energy, into hydraulic energy, that is pressure energy of water. This is a view of Metu Dam. The water storage area is called reservoir. The solid structure is called as dam. This powerhouse which is used to generate electrical energy by converting this pressure energy or kinetic energy of water into mechanical energy in this hydroelectric power station. This Metu Dam established in the year 1934. The length of the dam is 1700 meters, height of the dam is 37 meters. The capacity of the dam is 93.4 TMC, 1000 million cubic feet. The name of the reservoir, that is water store area, is called as Stanley Reservoir. Hydraulic turbine, it is used to generate electrical energy by converting the kinetic energy of water into mechanical energy in the hydroelectric power station. These are the components of hydraulic turbines. That is the reservoir, which is called as the water stored area. The solid structure is called as dam. Under the beneath of the dam, the large penstock diameter pipe called penstock, the water is carrying through the penstock and entered into the turbine. The turbine converts the kinetic energy of water into mechanical energy, rotational energy. This mechanical energy is converted into electrical energy using a generator. This is also the hydraulic power station. Here also the water is taken through the penstock and it is entered into the turbine and it is converted into mechanical energy. This is also another hydroelectric dam which shows the components of hydroelectric power station. And then classification of turbines. The turbines are classified based on so many factors, which are energy available, direction of flow of water, the head available at the inlet of the turbine, the specific speed of the turbine, and finally the name of the scientist who invented the turbine. We will see one by one. Turbines based on energy available at the inlet of the turbine. Here we will have two types of turbines. One is of impulse turbine, another one is of reaction turbine. In the impulse turbine, the kinetic energy of water is converted into mechanical energy. So here the energy available at the inlet of the turbine is kinetic energy. So when the penstock carrying water and strikes the blade of the runner, which is the part of the turbine, the runner rotates, the rotational energy is converted into electrical energy. After working in the turbine, the water directly flows under the bottom of the turbine. This example of the impulse turbine is Pelton wheel or Pelton turbine. Next one, based on the energy, we will have another type of turbine named reaction turbine. Here we will have kinetic energy as well as pressure energy at the inlet of the turbine. Here the water from the penstock is entered into the casing. Casing is a closed area cover which is in which the area of the flow is slowly reduced. So when area flow is slowly reduced means the pressure energy of water is converted into kinetic energy. So the kinetic energy moves the blades and which in turn runs the turbine. The rotational energy is again converted into electrical energy. So example of reaction turbine is Francis and Kaplan turbine. This is a comparison between impulse and reaction turbine. Impulse turbine, Pelton turbine. Pelton turbine, at the center we will have the shaft. Apart from the shaft, the runner, it is a moving blades. When water from the nozzle strikes the blades, it will rotate and the rotational energy is converted into mechanical energy. Here in the reaction turbine, the casing do the function of hydraulic function, that is converts the pressure energy into kinetic energy, and the kinetic energy rotates the blades, and the rotational energy is converted into electrical energy. Then based on the direction of flow of water into the turbine, we will have 4 types of turbine. One is of tangential flow turbine, radial flow turbine, axial flow turbine and mixed flow turbine. First one, tangential flow turbine. In the tangential flow turbine, the water enters into the turbine along the tangential direction of the runner. Example, Pelton wheel. Here, from the penstock, the water strikes the runner at the tangential part or the tangent, and it strikes the blade and it will rotate. The next one, radial flow turbine. The water flows radial direction into the runner, that is, the water flows perpendicular to the axis of rotation of the runner, then it is called as radial flow. Example, Francis turbine. Here we will see the water enters at the radial direction, that is perpendicular to the axis of rotation of the shaft, and also it leaves the turbine perpendicularly to the axis of rotation of the shaft. Example, Francis turbine. Next one, axial flow turbine. In this turbine, the water is entering into the turbine along the direction of parallel to the axis of rotation of the runner. So, when the water enters parallel to the direction of flow of shaft, then it is called as axial flow turbine. Example, Kaplan turbine. These two images shows the Kaplan turbine. Then mixed flow turbine. In the mixed flow turbine, water enters axially and leaves radially, or water enters radially and leaves axially. So, water is flowing through the runner in radial direction, that is perpendicular to the axis of the rotation of the shaft, and leaves the turbine in axial direction, that is parallel to the axis of the rotation of the shaft or runner. Example, modern Francis turbine. Nowadays, all the turbines are mixed flow turbines only. Turbines based on the head available. Head available is nothing but the pressure head or the head at the upstream side of the reservoir to the downstream side of the powerhouse or downstream side of the runner is called head. So, we will have 3 types of turbine based on this classification, based on this factor. One is of high head turbine. High head turbine, the head available is greater than 500 meters. Example, Pelton turbine. And medium head turbine, the head available is in between 80 meters to 500 meters. Example of this type of medium head is Francis turbine. And last one, low head turbine, the head available is within 80 meters. Example, Kaplan turbine. The next one, based on specific speed of the turbine. Specific speed is nothing but the turbine produces 1 kilowatt power when working under 1 meter of head. The speed of the turbine is called as specific speed. So, here also we will have 3 classification: high head, high specific speed turbine, medium specific speed, low specific speed. In the high specific speed, the speed is between 255 to 860, then the turbine is called as high specific speed. Example, Kaplan turbine. When the limit is in between 51 to 225, then the turbine is called as medium specific speed. Example, Francis turbine. When the specific speed is in between 8.5 to 51, then the turbine is called as low specific speed turbine, and example is Pelton turbine. Then based on the scientist who invented or developed these turbines, we will have the classification. Pelton wheel, invented by the American engineer Lester Allen Pelton. Then Francis turbine by British born American engineer. Then Kaplan turbine by Austrian engineer Victor Kaplan. This is a comparison between 3 types of turbine, that is turbine, Pelton turbine, Francis turbine, Kaplan turbine. So, the Pelton turbine comes under the category of available energy. Based on the available energy, it is an impulse turbine. Based on the direction of flow of water, it is a tangential flow turbine. Based on the head available, it is a high head turbine. Based on the specific speed available, the Pelton turbine is a low specific speed turbine. Based on the scientist, it is Lester Allen Pelton invented the turbine. Like that, Francis turbine, based on the energy, it is an example of reaction turbine. Based on the water direction, that is the flow of direction of water, it is a example for a radial flow turbine. Based on the head available, it is a medium head turbine, and the specific speed, it is a medium specific speed turbine. And last one, it was invented by the James B. Francis. And lastly, Kaplan turbine. It is also an example of reaction turbine, but based on the direction of flow of water, it is called axial flow turbine. Based on the specific speed, it is a high specific speed turbine. The specific speed is within 225 to 860. Based on the head available, it is a low head turbine. The head available is within or below 80 meters. It was invented by the engineer Victor Kaplan. We will see about the images which shows the hydraulic power station. This image shows the Adambagh hydroelectric power station near Niagara Falls. This image Okakuri power station near New Zealand. These are the large penstocks which are carrying water to the powerhouses. Then the powerhouses and the turbines which are used in our Tamil Nadu, Kundar to Nilgiris, the turbine used in this powerhouse is Pelton turbine. Then Marakavandi Dam, Tamil Nadu, semi-Kaplan turbine is used to generate power. Mettur Dam in Tamil Nadu, Francis turbine is used to generate power. Lower Minmutti in Kerala, Francis turbine is used to generate power. Then Sembukadavu, Kerala, Francis turbine is used to generate power. Chettipeda in Andhra Pradesh, semi-Kaplan turbine is used to generate power. So, in this session, we learned about the hydraulic turbines which are used in the power plant, that is hydroelectric power plant, which are used to generate power from the water. Okay, thank you.
Periyar Maniammai Institute of Science and Technology, Thanjavur.